Hey everyone, welcome back to BigBrains Tip. Today we are solving a really good backtracking problem called subsets. The problem is simple. For every element, we basically have two choices. Take it or skip it. Let's see how that gives us every possible subset. We are given an array of distinct integers. We need to return all possible subsets of that array. For 1, 2, 3, that includes the empty subset, individual element pairs, and the complete array. So in total, we get 8 subsets. Now, instead of trying to manually generate these subsets, let's look at each number as a decision. When we see 1, we have two choices, take 1 or skip 1. Then we make the exact same decision for 2 and then for 3. Let's start with an empty subset. For 1, we take it on one side and skip it on the other. Now we process 2. From 1, we can take 2 and get 1 and 2 or skip it and stay 1. From the empty subset, we can take 2 and get 2 or skip it and stay empty. Finally, we make the same take or skip decision for 3 and every leaf of this tree represents one complete subset. That's how we get all 8 answers. But we don't actually need to create this entire tree manually. We can build one path at a time. When we choose an element, we add it to our current subset. After exploring that choice, we remove it and try the other choice. That choose, explore, undo process is called backtracking. So our algorithm is very straightforward. We keep an index telling us which element we are currently processing. If we have reached the end of the array, we save our current subset. Otherwise, we first take the current element and continue recursively. Then we undo the choice and finally we explore the other possibility, skipping that element. We can start solving the problem. So first I'll be creating an empty list called result, and then I'm going to be creating the function for backtracking. So def backtrack, and I'll be taking two parameters. One is I and the another one is path. I refers to the current element that we are either trying to skip or add, and path refers to the currently building subset. And now I first have to check if I equals the len of nums. So initially we are doing this because when I equals the len of nums, it just literally means I have traversed the entire list of elements and now I need to add a copy of it to the result. So result dot append, I'm just adding a copy of it, so path dot copy, and I can just have written over here. And now we are going to do the take choice. So for this first, I'm just appending the current nums of I, and now I have to backtrack. So for backtrack is basically recursion, as you all know. So I'm calling the same function backtrack of I plus 1 with the subset path, and then once it is all being explored, I just have to pop it out. So path dot pop. So this will be the statement that we are doing for taking the element, and if we just want to skip it, we just don't need to add or pop it. We can just do backtrack of I plus 1 comma path. That's it. So since this being a function inside, we just have to invoke it. Backtrack. Initially I will be from 0 and it'll be an empty subset at first. So now I just have to return result. Let's see if it works. Cool. Perfect. The main idea to remember is really simple. For every element, make a choice, explore it, undo it, and try the other choice. That's the basic idea behind backtracking. And that's GYP5. Don't memorize TSA, recognize it.